In this video, we're going to be covering an introduction to OpenCV methods using GHPython Remote. So if you just go ahead and open the Grasshopper file intro to GHPython Remote, you should see something like this. So this top portion is just the import components to connect to our virtual environment, Rhino Remote. This should look familiar from the last video on installing and setting up GHPython Remote. So then underneath there, we have a toggle switch to run this GHPython Remote connection component. And then here we have several modules, which will be imported when this component is run. So to start, we can just go ahead and double click our toggle to true. This should open up this Anaconda terminal. We should see that our connection to the server is established. We can then minimize that terminal. So make sure not to hit the X, but just minimize the terminal so it's still up, and we should see it at our bottom taskbar. Now in this example file, we have a few different components to access basic OpenCV methods. All we have to do to use these is just set a path and then click the button to run the component. So just as a demo, I have an image input here. I'm going to just click through these so that we can visualize what each of these methods does, and then we can look at how to actually program them ourselves and look at some of the documentation for OpenCV. So this first component, grayscale, if we just click on this button, it opens up a new window down here in our taskbar, and we can see that it just takes the input reference image, so this path that we fed in, and it just makes it a grayscale or black and white image. If we just hit any key, so hit enter, then it exits out of that window. And then the next component we can just click is resize. So this is resizing the image to a particular aspect ratio. In this case, it's stretching it severely because the aspect ratio we've input is narrower than the reference image. The next component rotates the image, and we can take a look at the properties for the rotate. Then we have crop. So it's now cropped to the middle of the image based on a certain margin around the image. This is a threshold, but it's actually an OpenCV method called adaptive thresholding. So it's actually taking into account the surrounding context around the pixels. So it doesn't just do a flat threshold of whether the brightness value is higher or lower than a certain threshold input parameter. Instead, it's actually calculating based on a reference to the context. And the last method in our basic functions is contouring. So this is going to select the largest contour in the image and actually try to extract that object. So in this case, the parameters aren't tuned that well, so it's tracing out most of the border of the image, but we can see it come into the image in a few spots here as it traces out this contour. If we were to redefine these parameters, we may get it to more faithfully trace out contours like something like that, or maybe even just this object, or we could just trace all contours in the image relative to certain input criteria. These next two are slightly more in-depth methods in OpenCV. So when we open up the code to look at each of these, we will be able to see that. This first one, color swap, is going to take 2 input images. So in this case, we're giving it 2 input paths, and it is going to take the color values from one and map them onto the reference. So if I just click this run, it's taking these kind of muted color tones from a film camera photo and mapping those onto this reference Unger's image. And then this last one is canny edge detection. So when I hit run here, it's going to run on the image and actually extract all of the edges based on pixel cluster difference values. And we can get into the documentation and look more at this in a second. So first, if you wanted to change this input path or change the reference image here, all you need to do is right click, and then you can select one existing file. This will then input the path to that file. So just find any image on your computer. It should be a JPEG, and sometimes JPEGs are labeled .jpeg or some other extension notation. Sometimes OpenCV will have an issue with these. So if you are having errors, likely it is your extension not being able to be read inside of OpenCV with these methods. Okay, so first we're going to start by double-clicking in our canvas, typing GHPython script. So this is going to be similar to our start for most of these tutorials. And then we can right-click here and just rename this to grayscale. So we're just going to go through and replicate each one of these components and build them up from scratch. So in most of these, we need an I, which is going to be our image input, so I, and then we need an R, which is just to trigger whether we want to run this or not. And then we don't need any outputs as it's just visualizing in our terminal window. Now to input a path here, we can just double click and type file path, plug that into the I input, right click, select on existing file, and then select our reference image. And then we need to double click and button. And this gives a button that visualize this. Maybe we can just plug it into a panel. So when not clicked, the button equals false. So it's a Boolean value that equals false. But when we click it and hold it down, it's going to equal true. So if we just ever want to trigger a script one time based on a click or an input value, or we want to change the input value but not run it, and then when we click it and they're ready, we want it to compute, a button and then a R or run input Boolean is usually a helpful way to do this. So right now it's false, so we can set this up so it doesn't run when that button is false, but when we click it and turn it to true, then it will run the component. We can go ahead and get started remaking this component. So we don't need any Rhino script syntax as we're not doing any Rhino geometry manipulation right now, but we will need to import our script context as C. We need to import this because if we go up to the top here, we can see that the output from these import statements says import script context as SC, okay? So this is what we're going to need to copy into each one of our GHPython scripts if we want to use these modules, which it then says sk image equals sc.sticky, sk image, cv2 equals sc.sticky, cv2. So we can actually just go ahead and copy data only. And this is going to copy all of the text data in this panel. And this will make sure that we are importing all of these modules into our Python script editor each time that we need this. So we're going to just paste this at the top here. All of those modules that we need are going to be imported and accessible inside of our GHPython script editor. So the next thing to do is to actually set up this R Boolean value conditional. So we're going to say if R, so if R equals true, if R, and then we can do anything inside of this tabbed space. In this particular case, all we want to do is first read our image. So we're going to say image equals cv2 dot, and then call the OpenCV method imRead. So imRead. And for each of these methods, if we want to know more about them, we can't access a help document inside of Rhino. But if we just open up a browser and type OpenCV documentation, we can access pages like this. So cv2.imRead method loads an image from the specified file. If the image cannot be read because of a missing file, etc., then this method returns an empty matrix. Okay, so it's going to read cv2.imRead, and then it takes an input path and then a flag. In this case, we don't need the flag. So we just need to input a path. So we have a path, which is our I input. So we can just input I there. And now if we type print image, and just to debug this, I'm going to switch this button to a Boolean. So type bool, Boolean toggle, and we can just keep this true so that we can debug this script as we go. So hit test, and now we see this output here. So what this is the actual array of color values that represent the image. If we were to just print I, we would just see it printing just the path to that reference image. So we know that this method has actually worked. Now we're getting the color array output values from that image. So next we want to convert this image to a grayscale version of it. So we can say gray equals cv2 convert color. So cvt color, and this is going to take as an input an image, so img, our image that we read in here, and a color space, which in this case is going to be color underscore BGR, so blue, green, red, to gray. Now if we print gray, we can see that it is printing out our grayscale color values. We don't want to just print that. Instead, we want to actually display it like we had done previously in a separate window. You just need to say cv2.imShow, give an input name, so grayscale as a string, and then input our image we want to show, which in this case is gray. We want to show both the original image and the grayscale image. We can do that here as well. So original, we just need to input the original image variable there. So here it's going to first show us a window with our original, and then it will show us the image with the grayscale. Then in order for this to not cause an error, we need to say cv2.waitKey put 0, so it'll wait for a key to close that window. And then at the very end, we can say cv2 dot destroy all windows, and this will just close them out at the end when we're done viewing them. So if we hit test now, we have our original, which is a color value. It was a bit hard to tell those, so we may want to actually put our wait key in between each one of those so that they go at separate times. And now if we hit test, so we have our original first, which we can see just has hints of yellow in it. And then if we hit that key, it'll move on to the next one. So now we see the grayscale, so those hints of yellow are now gone. Then if we hit enter again, it destroys all those windows. So we can just hit OK. And now this component matches our reference here. Now we can just copy this and move on to the next one. So we're going to use our same inputs here and our same basic structure. So we can just reuse this component, but just change the name here and we'll change what's happening inside. So the next component is going to be size. So if we just zoom in, double click in here, we can get started on editing this. So we no longer need this gray image conversion. Instead, what we're going to want to do is resize this image. So we're going to say resize, which is going to be our new resized image, equals cv2 dot resize. And this is going to take an input image and then an input dimension, which is going to be our height and width. So we can put in 100, 200, or we'll make it even more exaggerated, 20 by 20. And then it needs a type of interpolation. So in case we are stretching this image, it needs to know how to recalculate those color pixel values. So we're going to use interpolation equals cv2 dot inter area, and then close those parentheses. And now we need to feed in resize into our im show here, not gray, and change grayscale to resize. And now we're going to just hit OK, and then press our button, and we get our original first, and then we get our resized here, which might be hard to tell, but that is it, 20 by 20 pixels. So it's absolutely tiny. We could maybe make it a little bit bigger so that we can see. So if we wanted to do that, we could just click back in, maybe make it 120 by 120, and OK. And this is going to still force it to be a square. So we now see it at 120 pixels by 120 pixels. So it's squished in the width axis. The next component is rotate. So we can just rename this to rotate. And now we can double click into this component. So we no longer need this resize. If you want to, you can keep compiling them all. So we could actually say our rotated image and use our resize to feed into here if we wanted to. So maybe we can do that for this one, but for each of the other ones, I'll just show one particular method. So rotated equals cv2 dot rotate. And this is going to take an input image and then a matrix of rotation. So our input image can be resized, and then our rotation, our transformation matrix is going to be cv2 dot cv2 dot rotate 90, which is 90 degrees clockwise. So this should rotate our image 90 degrees clockwise. Now if we feed in rotated instead of resize, OK, and then we can click the button to run. Now we see our image is both resized and rotated here. We can copy this again, change the name to crop, and then zoom in. In this case, cropping is as simple as just selecting certain pixels to show. So we can just select pixels within a certain range, but in this case, since it's an array, we need a range in the height axis and a range in the width axis. So we can say crop image or cropped equals, and we don't need an OpenCV method in this case. All we need is our image, and we just need to specify indices of the array that we want to set equal to the new image cropped. So we know that our resized image, which maybe we just take resize instead of our original one, is 120 by 120 pixels. So if we wanted a margin to be 20 pixels all the way around, and we want to crop it in those 20 pixels, then what we would want to do is say the indices 20 to 120 minus 20, so that's going to be 100. And then the same thing in the other axis. Now if we just copy cropped to rotated, title to cropped. We can hit OK. So now we have our original, and we have our resize, not rotated, but it is cropped in slightly on the image. The next component is the threshold method. So for threshold, first we're going to convert this image to grayscale. So we can start that by saying gray equals cv2 dot color, feed in an image. Then our color space is going to be color RGB to gray. And we need a threshold variable equal to the OpenCV method cv2.adaptive threshold. And this adaptive threshold is going to take an input image. So this is going to be our gray image. It's going to take a background color value. So in this case, this is white. So for this method, we can actually take a look at this documentation and see what each of these parameters is. So if we look at the documentation for adaptive thresholding and then click on adaptive threshold, we can see that this takes an input source image. So that's going to be our grayscale image. It takes a destination, then the source image takes a maximum value, so non-zero value assigned to the pixels for which the condition is satisfied. So if that condition is satisfied, if we insert 255, then it will be a white pixel inserted. And then the adaptive method, which in this case, we're using the adaptive threshold Gaussian C. Then it takes the threshold type. At the very top, it talks about some of these methods, but in this case, we're just using threshold binary, which will just give us black and white separation threshold. And then our block size, so size of pixel neighborhood that is used to calculate a threshold value. So you can think of this as how big is the context that these methods are running on. So how big is the kind of search context around each pixel, the neighborhood around each pixel. And then the last one, the constant subtracted from the mean or weighted mean. And then it just says normally it is positive, but maybe 0 or negative as well. In this case, the C is going to act as a kind of denoiser or a noise threshold. So lower values are going to accept more noise, higher values are going to accept less noise. Then we can take this threshold output and title our window threshold, and hit OK, and then run. So we can see right now it's filling that background color with white, which is that 255 value. It has a little bit of kind of speckling at the edges, but for the most part, it's tracing the edges fairly well. If we hit OK and then change some of these parameters so we can really look at what it's doing. First, let's lower this 4 at the end, that C value, down to 1, and then run this again, see what happens. So you can see that it's starting to accept a lot more noise from that constant being lowered. That's a pretty important value if you want to get clean results with this adaptive threshold. If we lower our neighborhood, then now we see thinner edge lines and we're losing some definition in some of these areas, but it's still generally the same as the larger neighborhood value. Now, this last component in the basic methods is going to be our contour. In this case, what we want to do is we want to convert the image to a grayscale image and then extract the threshold and then actually draw around the edges of that threshold. So we're not going to use adaptive threshold. We're going to use a more typical thresholding method. So this is just going to be called threshold, and we can still feed in a source image, which is gray, and then we're going to feed in a lower range. So let's say 220 and then 240, and then we don't need our adaptive threshold type there. So all we need is our threshold binary, and then we don't need these last ones. So just a source image maximum for the thresholding, and then our threshold type. And now we need two more things. So I'm just going to copy this in here. We can use the OpenCV method find contours, feed in a source image, and then input certain criteria for the contour extraction, which gives us all of the contours extracted from this threshold output. And then what we want to do is draw those contours on the image. So here they're just a kind of reference, not actually drawn out. So if we didn't do this next step in line 19 and we printed our contours there, all it's printing is the control points of that contour as index values in our array. So it's not actually outputting an image there. So we need to draw out our contours using cv2.drawContours. We need to feed it in a source image. And in this case, we can feed it all of our contours. And then if we give a -1 value, it'll draw all of those contours in our list that we're feeding it, which is all contours. Then a color input parameter. So right now, this is just going to be green because it is 0, 255, 0, so a 3-coordinate color value. And then the last one is the thickness of the line. So if we change this to 1, the actual thickness of the contour line drawn out on the image is going to be slightly thinner. So now we can just cut our original image, and now we want to actually preview this after, since our threshold is going to come first, and then our image is going to come with our contours drawn on it. So we just need to add one additional line, and I've also just resized it for the sake of speed because these can actually run for quite some time to compute the contours. But what we want to add is actually an imutils method called grab contours, and this converts the contours to a proper format for our draw contours. So now if we hit test here, we can see our threshold output in our window, and then if we hit enter again, we see contours drawn across that threshold. So it's tracing out the edges there of our threshold. The last thing to look at in this basic OpenCV introduction with GHPython is looking at saving these images to our desktop. So right now we're just showing these and then just destroying our window once a key is input. But if we actually wanted to save this for later, so if we wanted to save it out to use for future design processes or feed into something else or use one of the output images as the input to another one of these methods, instead of imshow, we're going to write cv2.imWrite. And this is going to take as an input a file path and then a source image. So first, our file path, we can give it any input file path. So I'm going to just copy one, and we want to make sure that this file path is set as a string. So all of that is our file path input. Right now, this is just a folder or a directory. So we want to make sure that this is actually passing a file name as well. So example.jpg will be our file name. We are going to set the input image to size, which should show our contours. Now, if we hit test, we don't see anything pop up and nothing is shown in a window here. But now when we go to that directory, we actually see example.jpg inside of that directory. So we see that it's actually working to save out the output image from that method. And you can use this any input directory and file name for the most part. Just make sure your extension is correct. And you can set this with any of the OpenCV methods. So you could use this with any of these previous ones as well. That's all for this introduction to OpenCV with GHPython Remote. In the next video, we're going to be covering an introduction to OpenCV still inside of Grasshopper, but connecting through just sockets inside of a GHPython scripting component. So we no longer will need GHPython Remote. It just gives a different option in case you actually want to run the code visually in your own terminal. And it also means you don't have to rely on someone else's plugin.